Alright, today I want to run you through some quadratic formula practice. So if you take out your week 7 warm-up, we talk about on the week 7 warm-up, we talk about the zero product property, we talk about how you can approximate the solutions by using your calculator, using the analyzed graph, or looking through the tables if they're whole numbers. For number 1, I've got an example of that zero product property where you just separate it and say, alright, if this times this equals 0, then this has to equal 0, or this has to equal 0. So our two solutions are negative 2/3 and negative 3. Those are our two solutions. Those are the two spots, those two x values where the graph crosses the x-axis. All right. Now, in order to do the quadratic formula, you have to have the a, the b, and the c values. So in order to do that, you could use the box, or you can use the double distributive property here. 3n times n is 3n squared. 3n times 3 is 9n. 2 times n is 2n, and 2 times 3 is 6. So just combine like terms, we get 3n squared plus 11n plus 6. So in other words, we are saying that a equals 3, b equals 11, and c equals 6. So far what we've done is we've talked about the axis of symmetry. Remember, the axis of symmetry is the negative b over 2a. I'm going to write that right up here. Negative b over 2a. Right? And then we've also talked about the discriminant. The discriminant, remember, is b squared minus 4ac. Right? And then when we put those together with the plus and minus and the square root of the discriminant, it becomes the quadratic formula. This is the quadratic formula. So it can be broken down into the axis of symmetry and the discriminant. And basically what the quadratic formula is doing is it's finding the middle of the quadratic, it's finding the middle of the parabola, and it's saying the solutions are this far away from the left and to the right of that vertex. So that's why we add it and we subtract it. Remember, we talked about this yesterday. If this was 0, you only have one solution. If this is negative, you can't take the square root of a negative, so you would have no solutions. That's where it'd be above or below the x-axis, all right, and never cross it. So let's actually do the quadratic formula for this one. So I'm going to say x equals negative b, and b in this case is 11, so negative 11 plus or minus the square root of b squared, so 11 squared, minus 4 times a times c. Alright, I'm going to try to put everything in parentheses that I'm plugging in here. Right? So I plugged in the 11, I put the negative in front because it's always the opposite, and then that's all over 2 times a. Right? And we tried to give you enough room over here. I'm not quite sure if we'll have quite enough room. It might be a little bit crammed. But what we want to do now is we want to kind of simplify this. So what I would do is I'd take the discriminant and just plug it in my calculator exactly the way you see it. 11 squared minus 4 times 3 times 6. Just plug it in exactly like that. All right? Then 4 times 3 is 12. And 12 times 6 is 72. And then we get 11 squared is 121 minus 72. So then we're left with, this is going to be the square root of, let's see here, 49. Okay. Now when you get a square root here where it is a perfect square, 49 is 7, square root of 49 is 7 times 7. All right, when you get that, then you're good. You can go ahead and take the square root of that, and then you can split it and you're all set. When you get one where it's not a perfect one, you want to make sure that you leave it as a square root. So if that was a square root of like 47, we're going to leave that as a square root of 47 because we want to be as accurate as possible, and if we were to approximate that, it'd be a decimal that would go on forever, never repeat. It's actually what we call an irrational number. The most infamous irrational number is pi, 3.14, and it keeps going and going and going and going. We approximate it as 3.14. Okay? So let's go ahead and finish solving this. So x is going to equal negative 11 plus 7, remember square root of 49 is 7, divided by 6, or x is going to equal negative 11 minus 7 divided by 6. So this is where we're getting the same or that we're talking about over here, because there's two solutions. This is where the plus minus splits it into two. Right? So negative 11 plus 7 is going to be negative 4 divided by 6, which is the same thing as negative 2 over 3, which you can see we got right over here. Or negative 11 minus 7 is negative 18 over 6, which is the same thing as negative 3. So your solutions should be the same, all right? Or really close to the same if you had to round your answers over here, okay? So we're going to try another one, but I want you to flip to, let's do one where we don't have to do much here. Let's go to number 10, okay? And no, take that back. Let's go to number 15. Number 15. So go to number 15 in yours, and let's go ahead and just write out what our A is going to be 4, our B is going to be 4, and our C is going to be 1. So 4, 4, 1. All right. Now let's set this up. X equals negative B, in this case B is 4, plus or minus the square root of B squared, so 4 squared, minus 4AC. So 4 times A, which is 4, and C is 1. And that's all over 2 times A, and in this case A is 4. Alright, so what we're going to do now is look at this stuff under the radical sign, our discriminant. What is this? 4 squared is 16. 4 times 4 times 1 is 16. What's 16 minus 16? 0. That means that there's only one solution. That means you don't need to split this one because you're going to add or subtract 0, right? So this just means it's going to be x equals negative 4 over 2 times 4 is 8, which is the same thing as negative 1/2 or negative 0.5. Okay, either of these are good answers, right? But there's only one solution because this equals out to be 0. All right. I'll do one more. If you're good with this, you can go ahead and stop it and go ahead and just continue on working on these. But I wanted to do one more. I'm going to do number 10. All right. I'm sorry, 19. 19 with the 10x squared. So A is going to be 10. B is going to be should do a little lowercase b and lowercase a. Okay. B is going to be negative 4, and C is going to be negative 1. Okay. So A being 10 and B being negative 4, so I'm going to say negative 4, which is basically plus 4, right? The opposite of negative 4 is positive 4, right? And then negative 4 squared minus 4 times A, which is 10, times C, which is negative 1, right? All over 2 times A, which is 10. All right? So now I'm just going to try to simplify this. Negative 4 squared. A lot of people make mistakes with this. Negative 4 squared is 16, not negative 16. I'm going to put the 16 right above it. Okay? And then negative 4 times 10 times negative 1, we're actually going to get a positive 40. So 16 plus 40. 16 plus 40 is 56. 56, if we're looking at the square root of 56, is not a perfect square. 49, 7 times 7, 64, 8 times 8, but 56 is not. So we're going to leave it as the square root of 56. And then we're going to write this out. X equals, we're going to say positive 4 plus the square root of 56 divided by 20. Or x equals 4 minus the square root of 56 divided by 20. Right? Now we are going to leave our answer like this. If you wanted to approximate it, you could plug this into your calculator as a fraction with the square root symbol and all that, and you'll get your decimal approximation of it. All right, and the same thing for this one. But we are going to leave it like this because that's the only way, without talking about simplifying those, that's the only way that we can keep the exact value of it. So 4 plus the square root of 56 over 20, and 4 minus the square root of 56 over 20. Those are our two solutions. All right, so go ahead and keep working on this in the back, and yeah, good luck.